This is June 2017, paper 6, variant 1. First question, a student prepared strontium nitrate crystals. The diagram shows some of the stages in this preparation. Label or identify the apparatus. This is called a glass rod or a stirrer. Glass rod or a stirrer. Both are accepted. What's used to add strontium carbonate to the acid in stage 1? As long as you want to add a solid without measuring its mass, you can use a spatula. Name the acid used. Name the dilute acid used. He started with strontium carbonate, he ended with strontium nitrate. So the acid should contain the nitrate ion, so it is nitric acid. Okay. Give one expected observation in stage 2. He's adding a carbonate to an acid. Carbonate with acid produces carbon dioxide, so you will see bubbles or fizz or effervescence. Why is heat not necessary in stage 2? The reaction of carbonate with acid is very exothermic, so the reaction rate is already fast at room temperature. No need to heat a reaction that is already fast in rate. Reaction is already fast at room temperature. Which of the reactants is in excess? The reactant that's in excess is the one that remained, okay? So the acid was all neutralized, but there is unreacted solid, and this unreacted solid, of course, is strontium carbonate. Strontium carbonate is the reagent is left behind. Crystals of united could be obtained from the mixture in stage 3. Take care. Here you have the mixture in stage 3 with the unreacted solid and strontium nitrate solution. How can you obtain strontium nitrate crystals from this mixture? Number 1, you need to remove the excess unreacted solid. So you need to filter to remove the excess unreacted solid. You will remove this by filtration, and will remain for you the strontium nitrate solution. Heat till crystallization point and leave it to cool down. So filter, this is step number 1. Heat or evaporate till crystallization point and leave the solution to cool down. You will have crystals. You can then filter, wash, and dry the crystals to obtain them in a dry form. But the marks are on filter, heat till crystallization point. That was question 1. Question 2, it's a reaction between sodium thiosulfate and 2 aqueous solutions of potassium iodate labeled C and D. When he gets the same substance, potassium iodate, but he gets 2 different solutions, that means they have different concentration. Okay? Whenever you see him using a measuring cylinder, this is an inaccuracy because we could have used a burette or a pipette to make it more accurate. He filled the burette with sodium thiosulfate. Try always to imagine the experiment in a lab. Okay, he filled the burette with sodium thiosulfate, and then he poured solution C, potassium iodate, in a conical flask, and he added to the flask 10 centimeter cube of sulfuric acid and 1 gram of potassium iodide. Okay, he mixed the contents and he started to add the sodium thiosulfate slowly from the flask and swirl to make the contents mixed. When the solution turned pale yellow, he added something called starch solution, and it turned the whole mixture blue-black. Okay, and he's asking you to take the burette readings. Type the burette readings 38.3, 4.1, 34.2. That's the final, initial, and the difference. Take care, you must always take your readings to 1 decimal place if you're dealing with a burette. Experiment 2, the conical flask was emptied and rinsed with distilled water, and then he repeated the experiment 1 using solution D instead of C, which means he used a different solution with a different concentration. The final burette reading 20.8, 3.7, and the difference 17.1. Okay, CI, which solution of potassium iodate, C or D, was the more concentrated? To answer this question, you need to see how much sodium thiosulfate was used when using each solution. Solution D used 17.1. Solution C used, you always go for the difference, okay? Used 34.2. So definitely, solution C was more concentrated as a greater volume of thiosulfate was needed, okay? Solution C was more concentrated, that takes a mark, as a greater volume of thiosulfate was needed. How many times concentrated was this solution? When he asked this question, you should always know that there is a mathematical relationship between the 2 differences. So the first difference was 34.2, the second was 17.1. Always to get the ratio, divide the larger number by the smaller one, you will find that the ratio is 2 to 1. Okay, so it was twice the concentration. It was twice the concentration. Okay. Question D. Predict the volume which would be needed to how much is the volume I used from solution D. I need to read the question again. He used 20 centimeter cube from solution C in experiment 1, 20 centimeter cube of C. And then in the second experiment, he told you that the same experiment was exactly repeated, but using D instead of C, which means in this experiment, he used 20 centimeter cube of D. He's asking how many centimeter cubed of sodium thiosulfate will be needed if you use 30 centimeter cube of D, okay? But simply, the 20 centimeter cube used of D required 17.1 centimeter cube of thiosulfate. So using the crisscross method, you could easily get it. How many centimeter cubed are required if we used 30 centimeter cube? 30 times 17.1 divided 20, تطلع 25.65 centimeter cube. The unit is for a mark, and the answer is 4 mark. State two sources of error using in these experiments, using a measuring cylinder, of course, and carrying out the experiment once. When you're doing something titration-like, or when you're doing any experiment, generally, it's always better to do the experiment several times and take average of the results in order to minimize the error. So using a measuring cylinder is one of the sources of error. The second one is carrying the experiment once. The improvement is to use a burette or a pipette instead of a measuring cylinder and to repeat the experiment instead of doing it once, okay? So if you said using a measuring cylinder, this is the improvement. If you said doing the experiment once, this is its improvement. Cation and anions. Two solids E and F were analyzed. Solid F was potassium iodide. So this means we have the cation, potassium, and the anion iodide. Tests were carried out. Appearance of solid E is a green solid. When you see a green solid or a colored solid, you need to memorize yourself, to remember that the metal is a transition metal, and that green solids may be one of the cations that give me green is iron 2 or chromium, which gives a gray-green solution, and its compounds are gray-green in color. So you'll be thinking iron 2 or chromium. Solid E was heated gently, then strongly, the solid turned black, okay? Heating gently, then strongly is very important, and we'll know now why. Test 2, dilute sulfuric acid was added, rapid effervescence, okay? Take care, solid E has effervescence when you added an acid. When we add an acid to a metal, a gas is produced, and we add an acid to a metal carbonate, also a gas is produced. Excess aqueous ammonia was then added to the mixture. Pale blue PPT was formed. Pale blue PPT is distinctive for copper 2 positive ions, which then dissolved to form a dark blue solution, okay? This is definitely copper 2 positive ions. A flame test were carried out, blue-green color. This is also the flame test of copper, although you don't have to memorize it that much, because you can also know that it's copper from the test of ammonia. In terms of safety, explain why, in terms of safety, explain why it's necessary to heat gently at first. You heat gently at first simply because if you heat the tube strongly directly, the tube might crack or the solid might spit out of the tube. Solid spits out the tube because of the heat. It can go out of the tube, or the tube gets high temperature of flame, it could crack. So heat it gently and then strong. Identify the gas given off in test 2. It is carbon dioxide because lime water turned milky. The gas was tested with the test for carbon dioxide and it gave a positive result. Identify solid E. You knew in the Phe carbon dioxide, and carbon dioxide comes from carbonate ion, and you knew that there is copper. So the solid is copper carbonate, okay? Type. Complete the expected of solid, which was the 2E group 1, whose compounds all give white solids, okay? So it is white in color. To the first portion, he added excess, he's now testing F. To the first portion, he added sodium hydroxide. Sodium hydroxide and potassium, they don't give a result, no change. Potassium is not in the table of cations. To the second portion, he added aqueous silver nitrate after adding nitric acid. Silver nitrate is the test for halides. Since we have one of these halides, which is iodide, the result will be yellow precipitate. Chloride gives white precipitate, bromide gives creamy precipitate. Flame test was carried on F, which contained potassium ions. Potassium gives lilac flame. Describe how you carry out the flame test. This is a very important question. How to do a flame test? First of all, you get something called platinum wire, okay? Platinum wire. This is a wire made of platinum to endure the high temperature. You add the solid on the wire and you burn the solid in the blue part of the flame, or just say in a hot flame. You need to burn the metal in the hottest part of the flame, okay? It will catch fire. You will notice the color of the flame, and this will make you know which metal you're dealing with. And then you clean the wire by concentrated HCl. You can't clean a wire where you burned metal on by water. You clean it by concentrated HCl because the HCl reacts with the metal and removes it, okay? These are three points. You get 2 if you said any 2 of them, okay? Use a platinum wire to put the solid into a hot flame. Hot flame is with a mark, worth a mark. Platinum wire is worth a mark. If you said clean it with HCl, also this is worth a mark. You get maximum 2 marks. Finally, the last question, question 4. A sample of furniture cleaner contains aqueous sodium chloride, aqueous ammonia, and sand, okay? It's always useful to write the substances you have. Aqueous sodium chloride, aqueous ammonia, and sand. Sand is silicon dioxide. Give a test to show the presence of ammonia in the mixture. The test of ammonia is always red litmus paper turns blue. It turns damp red litmus paper blue. If it's the gas, the aqueous ammonia, just add the litmus paper, it will turn blue. Since sand is a solid, so it will not affect the litmus paper, and aqueous sodium chloride is neutral, so it will not affect the litmus paper. So aqueous ammonia solution will directly turn the red litmus paper blue. Okay, plan an investigation, BI, to obtain pure water from the mixture, okay? So this is a mixture of sodium chloride solution, which means it's dissolved in water, and ammonia solution, which is dissolved in water, and you need to obtain the water from the mixture. Heat the mixture, water will evaporate, try to pass it through a condenser. Of course, you need this apparatus, pass it through a condenser, okay, delivery tube passing through the condenser, and condense the water from the other side. Heat the mixture worth 1 mark, condense the vapor worth the other mark. It's useful also to say simple distillation, yani, but in the mark scheme, he gave the marks on heat and condense. Double I, pure sand from the mixture. If there is a sand at the bottom of this mixture, you can easily get it by filtering the mixture. And always, please remember this, always, when you filter a solid, wash it and dry it directly. Wash it and dry it to obtain it in the best possible state. This was June 17, paper 6, variant 1 by Mr. Marco Mehta.